We begin lesson 2 with a warm-up. We're going to review some material from yesterday with negative exponents as well with rational exponents. So let's start off by looking at this first question. We notice that we have a negative exponent, so the first thing I'm going to do is reciprocate my base. So instead of negative 5, I'm going to have 1 over negative 5, and that'll be the exponent 3. And then I cube both the numerator and denominator to give me 1 over negative 125. And again, I get that from because the negative 5, if I cube that, that gives me negative 125. So just to keep that in the back of your head. For the second one, I'm going to be using that little rule that we learned yesterday, and I'll reiterate it right here. If I have a base of a to the exponent m over n, that is the same as writing the nth root of a to the exponent m, or we can even write it as the nth root of a to the exponent m, where the m is underneath the root sign. Sorry, not a. It'll be n over there. So n. So it's up to you. Which one do you want to use? I'm going to use the first one here to solve this this question. So I'm going to rewrite it as the cube root, because that's a 3's in my denominator, the cube root of 27, and that's all raised to the exponent of 2. Well, the cube root of 27 is 3, and 3 squared is going to give me 9. For the next one, once again I see a negative exponent, so I'm going to do two things. I'm going to first reciprocate my denominator, so to 225 over 16 because of the negative, and I'm also going to rewrite my exponent as a fraction. And based on that, I know that I can rewrite my expression as 225 over 16, which once I take the root of the top and bottom, I'm left with 25. No, that's not 25. 225 square root is 15. 15 over 4. So there's our warm-up for number 3. And the last one for 4. We just want to evaluate this. So I have the 5th root of negative 32. Well, in your calculator, it'll give you negative 2. And then I have the 6th root of 64 to the exponent 5. So the 6th root of 64 is going to be 2. And then it's 2 to the exponent 5. So that's negative 2 times 32. And my final answer is negative 64. So there's your warm-up. We're going to look at some slightly more complicated questions next. So here in part 1, we're simplifying expressions with rational exponents that are a little bit more involved. In this first one, and there's many ways to approach this, I'm just going to choose one which I find to be the most intuitive. You might approach it differently, which is fine. In fact, give it a try, see if you arrive at the same conclusions as I do, and that means you're on the right track. So what I'm going to do is use my exponent rule by bringing this 1/3 into the bracket, okay, with each factor. So what do I mean by that? I mean I'm going to have 27 to the exponent 1/3 times, and I won't write the times there, a to the exponent negative 1. Now how did I get that? Well, just isolate this part over here. Let me do it in red. A to the negative 3 and 1/3. Well, remember, that's a negative 3 times 1 over 3. I'm multiplying the exponents. So if I just focus my attention on the exponents here, well, negative 3 times 1 over 3, that'll just give me negative 1. And that's where the negative 1 comes from in this step of the equation. Finally, for b, same type of logic. B to the exponent 12 divided by 3 is going to give me b to the exponent 4. Same thing for my denominator. I'm taking now the 1/2 as my exponent and applying it to each of my factors in the denominator. So remember, 1/2 as a radical is the same thing as taking the square root. So I'm taking the square root of 16. Well, you know what, I'll save that for a second because I want to match the top. A to the negative 8, I'll have a to the negative 4, and then I will have b to the 6. And now I'll actually do the calculation. So the cube root of 27 is 3. I have a to the negative 1, I have b to the 4, all over 4, a to the negative 4, and b to the 6. And if I simplify this, 3 over 4, I get now a to the exponent 3, and I get b to the exponent negative 2. Remember, what I'm doing is I'm dividing the a's, dividing the b's, and that means I subtract the exponents. And that's how I get the 3 and the negative 2. Now this usually could, well, not usually, but could be a final answer. However, we like to express them with positive exponents, even though this question doesn't ask for it per se. I'm just going to rewrite this with a positive b term with a positive exponent. So there's your answer for example 1. Now in example 2, we're actually explicitly asked to solve the expression or simplify it and make sure that we express our answers in radical form with positive exponents. So let's take a look here. I'm going to do one step at a time with my numerator and denominator. For the numerator, I'm going to begin by combining these two terms together. So that'll give me x to the exponent negative 3. Again, I'm multiplying the 18 by the negative 1 over 6 to give me negative 3. And that's all over. I'm going to break this up here. 243, and that's the 5th root of 243 times the 5th root of x to the exponent 10. And that's all to the exponent, let me move this out of the way, that's all to the exponent of 0.5 or 1 over 2. Just writing that there. Now, you may be asking me, well, how did you separate this into this? Remember that rule from Unit 1 when we were looking at radicals? If I have the square root of a product, that's the same as the product of the square roots, okay? And this applies for any value outside. If I have an n is any integer, I can separate it into two separate nth roots and then multiply them together. So I'm just applying that little technique to my denominator. So let's get rid of that, and let's do some evaluation here. So my numerator I'm going to leave as is for now. So I have x to the negative 3. And my denominator, well, the 5th root of 243 is going to be 3. And the 5th root of x to the 10 is going to give me x squared. Now again, over here you might be wondering, well, how did I go from this to this? Well, many ways. One way you can look at it is I can rewrite that radical as x to the exponent 10 over 5, which is just x to the exponent 2. So keep that in mind again when simplifying. Get that out of the way. And of course, this is all to the exponent of 1/2. I'm still not at the stage where I want to apply that 1/2 because I have these common x terms here. So what I'm going to do is rewrite it as x to the exponent negative 5 over 3. I just combine these two together, the x terms, and that's all to the exponent of 1/2. And finally, let's bring this over here. I'm going to apply the 1/2. So I have x to the exponent negative 5 over 2 over 3 to the 1/2, which gives me what? 1 over 3 to the 1/2. I'm going to bring the x into the denominator, so I get 5 over 2. And if I rewrite that, I get 1 over root 3, and then I can have root x to the 5. So, I mean, the last step, I think either one of these two are acceptable because, you know, I do have positive exponents in the second last one, or I can write it in radical form in the last one. Either one is fine. Next, we're going to look at exponential equations. Now, for exponential equations, it's quite simple once you've set up the problem properly, because from then on, you'll notice it's just a bunch of grade 9 work. So let's look at our first example here. I have an equation where the exponent is what contains the variable. So what I'm going to be doing is rewriting the 64 as a power of 2. Why? Because my other side has 2 as its base. So how do I do that? Well, I'm usually going to give you questions in your homework that you can kind of figure out what the base is going to be, and then either by a process of trial and error or just familiarity with powers of whatever that base is, you can rewrite the number as a power with that specific base. Once you get that, you'll notice that my bases match up and I can equate my exponents, i.e. I can write 2x minus 1 equals 6. But that only happens once you have identical bases. If I had a 3 over here and a 2 over here, I could not do this equation on the next line. Okay, need to have identical bases on each one. So let's go ahead here. See, this is what I meant. At this point, it's just grade 9 linear equation. I get 2x equals 7, and I get x equals 7 over 2. For the next one, you'll notice that our base is, well, 36. Yeah, I can recognize that's a power of 6, and I have 6 on my left-hand side. So I'm going to do the same thing. When you write the equation, I'll write 6x plus 3 equals 6 as my base, 2 as my exponent, x as my exponent outside. Remember, I'm just rewriting 36 as 6 squared. And before I make the exponents equal, I am going to combine these two together. It's a power raised to an exponent. Same base means I can equate my exponents. So I have x plus 3 equals 2x, which means I get negative x equals negative 3, or just x equals 3. And there's your answer for number 4, example 4. Okay, for example number 5, you'll notice that our bases are different, and I can't really write one as a power of the other. 625 is certainly not a power of 125, and vice versa. However, based on experience and doing lots of homework, you will notice that 125 is a power of 5, and 625 is also a power of 5 as well. So what does that mean? It means that I can rewrite my equation here, where my base is 5 cubed to the exponent x minus 2, and I have 5 to the exponent 4, and my exponent is 2x plus 1, and I can now multiply out my exponents. So I have 5 to the exponent 3x minus 2 equals 5 to the exponent 8x plus 4. Same base means I can equate the exponents, and if I solve here, I'm left with negative 6 equals 5x, which means that x is equal to negative 6 over 5. Okay, for our last example, number 6, we're given an equation once again where we have bases that certainly do not look similar at all. I have a 9 here and a fraction here, which is something we haven't seen yet. However, you'll notice that the 9 and the 243 do have one thing in common. 9 is a power of 3, and 243 is also a power of 3 as well. I believe that's 3 to the exponent 5. So how am I going to use these facts to rewrite my equation above so that I have a base of 3? Well, my left-hand side is quite simple. The 9 I can replace with 3 exponent 2, all to the exponent x minus 5. And the right-hand side, well, 243, what I'm going to do is rewrite that as 243 to the negative 1. Again, I'm looking at my fraction here, and I'm rewriting it as the reciprocal with a negative exponent. Now the 243, well, like we said, that's 3 to the exponent 5, negative 1. And so this line is going to be 3 to the exponent negative 5. Lo and behold, I get 3 2x minus 5. Actually, I'll just keep it in the form that I have it here, so I'll have 3 squared. 3 squared to the exponent x minus 5 is equal to 3 to the negative 5, which is 2 times x minus 5, 3 to the negative 5. Equate this with this, and what am I left with? 2x minus 5, well, actually 2x minus 10 is equal to negative 5. In other words, I can write this as 2x equals 5, which means that x is 5 over 2.